This is the March 19th check-in that we did today. We're looking at the combustion of acetylene gas. I did this during our session together, but if you want to go over it again, here it is for you. So we have a balanced equation. That's our first step. First step is a balanced equation. The second step is we need to figure out what we're given and what we want. So in this question, it says how many grams of carbon dioxide and grams of water are produced when 52 grams of acetylene burn in oxygen. So I have 52.0 grams of acetylene. And what I'm going to is grams of carbon dioxide and also grams of water. Okay, so third step is to set up my grid. So I'm going to start with 52.0 grams of acetylene. If you need your double mole map out, that's great. You can look at it. In order to go from grams, we're going to need to convert to moles. So 1 mole of C2H2 over, and we need our molar mass of C2H2, which is 2 times 12 plus 2 times 1. That 12 and the 1 came from the periodic table as the molar mass of carbon and the molar mass of hydrogen. And so we get 26 grams. Okay, so my grams have canceled and now I'm at moles, and now I need to use the mole ratio. So if I look at my equation, I know that 2 moles of C2H2 yields 4 moles of CO2. And if you look, that 4 comes from here, and let me pick a different color, purple. The 2 comes from here. So that's where those values come from. So now I'm at moles of CO2, and I want to get to grams of CO2. So 1 mole of CO2, and I need the molar mass of CO2, which is 12 plus 2 times 16. So 32 plus 12 is 44 grams of CO2. So then I'm just going to plug and chug. So we use the calculator right now. I have 52 divided by 26 times 4 divided by 2 times 44. And what you should get is 176 grams of CO2. Okay. So now let's do the second problem, or the second one, which is this is the second one, grams of H2O. We have 52 grams. We're starting exactly the same way. I need to go to moles of C2H2. So it's exactly the same up until this point, but now we're a little bit different. I need moles of C2H2 on the bottom, so I have 2 moles of C2H2. I'm going to link this up here. And then up top, I am going to use, now, let me erase my 4 moles. Now, let me do the blue. For water, we're going to use 2, okay? So, 2 moles of H2O. So it's a 1-to-1 ratio, right? 2 moles to 2 moles. Okay, and now I need to go to grams of H2O. So 1 mole of H2O has the molar mass of 18 grams, right? Because my molar mass of H2O is 2 times 1 plus 16, which is 18. Okay, so what I do here is I plug and chug. I say 52 divided by 2. 52 divided by 52 divided by 26 times 2 divided by 2. You can leave that step out if you want. Times 18. And what you get is 36 grams of H2O. I'll move my units here. Okay? So those are the 2 stoichiometry problems. The next one says how many moles of water are produced when 64 grams of C2H2 burn in oxygen. So again, we have our balanced equation, which is up here. We're trying to go from 64 grams of C2H2 to moles of H2O. Okay, so I know what I'm trying to do. Step 3 is setting up my grid. So 64 grams of C2H2, 1 mole of C2H2 is 26 grams, right? Because that's my molar mass. And then I'm going to use my mole ratio of water to C2H2. So if I look at my equation, 2 moles of C2H2 and 2 moles of H2O. So 2 moles of C2H2 and 2 moles of H2O. So in this problem right here, I had to go to grams, so I needed to go one step further. But this problem right here, I am going to moles. So I only stop after 2 steps. And when I calculate 64 divided by 26, so 4 is plug and chug, 64 divided by 26, I should get 2.46 moles of H2O. So that's how to do it.